Coming up on this episode of the IoT Inc. Business Show.
There is a principle in system engineering, a system which should take decisions in real time cannot be only based on data. Because as I mentioned, like you and me, I didn't come today to you with all the books and white papers I read in my life to answer your questions, right? We are real-time system. We take decisions, we take actions mostly in real time and instantly. So a digital twin will be exactly the same.
We've discussed the digital twin at length, but what is the cognitive digital twin? Is it possible to develop cognitive computing models with our data to endow our digital twin with artificial intelligence? The answer is yes. And in this episode of the IoT Business Show, I speak with Dr. Ahmed El Adl about how this is done and the situations when an AI approach to reaching insights may be better than an analytics approach.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com. With me today on the IoT Show is Dr. Ahmed El Adl. Ahmed is the Chief Technologist of the Accenture Global Artificial Intelligence Council for Resource Industries. His focus is leveraging artificial intelligence, machine learning, and the industrial Internet of Things to create intelligent solutions for asset-rich industries such as energy, utilities, chemical, and natural resources. Ahmed, welcome to the show.
Thank you, Bruce. Good morning to you.
Good morning. It's been a while. I think we first met a couple years ago on LinkedIn, and we were supposed to get together, but something happened, right? I can't remember what the details were.
That is correct. Finally, a digital twin. Reintroduced us.
That's right. I read your cognitive digital. He's jumping right into it, everybody. I read your cognitive digital twin article, and I go, wait a second. I think I know this guy, sort of. And then I reached out. So, yeah, very happy that we can talk again. Well, since we connected, what have you been focusing your time on?
Oh, yes. I was mainly focusing on the major idea I have now. How can we all move to the concept of a digital twin? Mm-hmm. And it takes everything you, and everyone learned in his or her life. And this is actually kind of a dream of mine. And if you remember, Steve Jobs said software is eating the world, and I believe, and it is already eating the world. We know, all of us, software is dominating and replacing a lot of physical devices and components, and this was my main focus over the last few years. Mm-hmm. And we are here today talking about the cognitive digital twin.
Well, maybe I gave a little bit of a bio, and it's actually funny. I didn't even know that you actually worked for Accenture until I just read about it when I read the bio. So maybe give us a little bit of background of your history and how it led you to this digital twin research and work that you're doing now.
Exactly, sure. So I started my career on the academic world. Actually, I was always fascinated by robotics, late 90s, like nearly everyone of our generation, and today the same. It didn't change it too much. So I started my career on the academic side.
Okay.
I did my PhD in robotics and postdoctoral in what we called biologically inspired robotic systems using machine learning, what again, artificial neural network, not the statistical mathematical methods. And as you know, in the late 90s, AI was starting to have its second cold winter. So I moved to the software world, and I joined a company you know very well, SAP, the enterprise software company, and continued with SAP for some time and left to the software consulting world, went back to SAP, and over the last few years, Bruce, I focused on maybe like I imagine myself like an enterprise right now. So the digital transformation, I had the AI background, the robotic background, the system engineering background, and the enterprise software background. So if you join both categories of experiences, you will be talking about a company trying to transform itself to a digital cognitive company. And this is what I have done to myself over the last few years. I am joining my artificial intelligence robotic experience with my enterprise software experience together. And we know different waves of technologies like industrial IoT, Industry 4.0, Industry X.0, smart products. So this is what I'm doing since maybe 4-5 years. And as I mentioned earlier, my key focus is the digital twin and the smart products. As you mentioned earlier, I joined Accenture about 4 months ago. And my focus exactly is to do the same. And this is actually, it is a good marriage between me and the Accenture global strategy. We are driving the application of artificial intelligence into every industry globally. Ask yourself one question. If you have the machine learning capabilities we have today in memory computing for big data analytics, you have cloud computing, edge computing, all of those technologies coming together, offering us a lifetime opportunity. I am seizing it right now, and Accenture is helping our customers globally to seize the same opportunity.
No, and you're right. I mean, it's interesting with your AI background. I would say that's the cutting edge of IoT, is being able to utilize AI, and I'm sure we're going to be discussing that in our conversation. But something else is very applicable, obviously, and that is cyber-physical systems. And this is something, along with software-defined networks, that really got me thinking in what I call a software-defined product, which is more or less a superset of the digital twin. But talk to me a little bit about cyber-physical systems, and where do you see, I mean, it's cyber, physical, digital twin, and physical twin. Where do you see the differences between a cyber-physical system and the IoT, or I should say the cognitive digital twin or digital-based IoT solutions that more or less the cutting edge that we're seeing today?
Sure. All of them are connected. All of them are parts or generation of technology evolution. When NASA started to create systems which have been called later on cyber-physical systems, so we have a physical system and some digital component embedded even on the digital control side, BLC and SCADA system and all of those systems. And in parallel, we had a different trend called machine to machine. So the CPS or cyber physical systems evolved, leveraging the different technologies from electronic technology, digital technology, software technology, communication technologies together. Parallel, we needed what we call, we need communication between those machines, right. What we called machine to machine. But as you know, maybe in the early 2010, maybe 2000, early 2010, we started to talk a little bit about what has been called later on IoT, because we had more the rise of cell networks, the rise of software-defined networks, and software capabilities, computing capabilities, the available computing storage capabilities everywhere in a very cheap costs. All of those technologies came together, and people started to think, okay, can I use all of those technologies to upgrade what I have, to design a new generation of products? If you see, for example, Cisco in their network hardware, data center business, they used all of those technologies, and they started to say, okay, can I update everything I have? And then we got the software-defined networks, yeah? Mm-hmm. And on the other side, Jeff Emlet at GE seized the opportunity. He's a very smart guy, and seized the opportunity and started to talk about industrial internet, And industrial internet, as you know, is reshaping, or the concept of industrial internet is reshaping GE as we speak, is reshaping Siemens, is reshaping similar large organization. Smartly, they took actions on time. So now we started to see, okay, is it in Internet of Everything, or Internet of Things, or industrial internet, or all of this acronyms and new expressions are confusing many people, but for me personally, they are not confusing because the first iteration of industrial internet and IoT and IoE and all of those terms, I said, we have everything today to make the digital twin a reality. And this is where we are today, Bruce. So CPS, machine to machine, we're the first generation. Now we are talking about digital twin and IoT as the second generation. And I am kind of evangelizing for cognitive digital twin before we make it just a digital twin and make it as just a digital stuff. Let us make it smart stuff. All the designs, all the products we are going to design should be smart by design.
Okay, I want to get into the cognitive, but I think what you're saying then is where we were in cyber physical systems essentially is the first generation, and I think what you're saying is then IoT, industrial IoT, or now, with the cognitive digital twin or digital twin are more the second generation. Would that be a good way of classifying it?
Yes.
Okay.
Yes. So the trend now is to talk about digital twin. I say let us skip one trend, and instead of moving from cyber physical systems, let us move to smart systems, which I call cognitive digital physical systems.
Well, let's dig into it, because when I read your article, I found it very, and I'm going to be linking to it in the show analysis notes for everybody. But please explain then, what is the difference between a cognitive digital twin and a regular digital twin? We've been speaking, we've had a mini-series now of 4 episodes so far on the digital twin, and that's what caught my eye, the cognitive digital twin. So maybe you can discuss this there.
Sure. Let us go back to the digital twin itself. As of today, many companies think, I believe wrong, that a digital twin is a simulation environment. We know that we have a lot of simulation environments simulating physics, engineering, parameters and phenomena, whether in space, in engineering, and physics, you name it. So some companies coming from this field, the engineering or scientific simulation field, are still dominating the field of digital twin. And when I talk with clients, at least I have at least one talk about digital twin every week, and they think the same. And I say, no, I think we have enough simulation tools. We have them in the universities and the industries. We have enough. We do not need to invest more time to upgrade simulation environments. What we need to do is to do more than that. And I use always, Bruce, the human analogy. What I mean by that is, as humans, we know that we have physical body and something else. Call it whatever you want to call it. Let us call it the digital part for us, for the sake of this discussion. So we have our physical part, physical body, and the digital part. Our evolution, I think, about 11 billion years. So it took 11 billion years to be as we are today. This is the optimal way or shape I envision for smart machines in the far future. But what I wanted to say here is, we see that some companies create environments, we called it digital twin, to collect some data, some parameters, and do some simulation. I see more than that, and maybe I define the digital twin or cognitive digital twin today, Spruce, as it is the representation. First, there is a physical twin and there is a digital twin. The digital twin should be, in my opinion, a complete representation of the physical twin. And secondly, I don't want just to collect engineering data, operational data, material data, and all of those data and dump them in cloud storage and call this digital twin. I want also that this digital representation, this digital twin, will influence the design of the physical twin. What I mean by that is that it is cheaper, it is environmentally friendly, it is sustainable if we do things in the digital world. If you have a machine today and you replace tasks the machine does today using physical components and replace such functionalities with, or components with, digital components, it would be cheaper, it would be better. So I want that the digital twin take over by time more functionalities from the physical world and do it in the digital world. So this is what I call augmentation. So it is a digital representation of the physical twin. It is augmentation to the physical twin. The third one is, it is a companion. The digital twin will be a companion to the physical or to its physical twin over the life cycle. And by the way, imagine you have a turbine and it's a digital twin. And later on you decide that the turbine is not usable anymore. You will have the digital twin with all the experience, all the knowledge and data, the digital twin collected over the turbine life cycle, and take this digital twin and use it to start the digital twin of another turbine. You see the analogy here between the humans? It is the evolution or kind of semi-automatic evolution of physical machines. You will not get rid of the digital twin. It is digital. It is digitally stored knowledge and data, and you can use it to evolve your products automatically. So this is what I mean by, if you want to understand the digital twin, look back into our evolution and ourselves and how did we evolve. And we see, if we talk with my friends here at MIT or Harvard, they think the same. They learn from the nature, our evolution, in designing complete new systems.
Okay. So I think I'm getting the genesis, so to speak, of what you're saying here. So on one side, hearing is something similar. In particular, when you say we want to describe the physical twin. Okay, that takes me to CAD, that takes me to the outside surface, that takes me to a visual representation. Then we go a little bit further to a physical representation. Then you're talking about giving it augment with other information. And that all fits squarely with current thinking. And I think everyone's listening now is nodding their heads. Yeah, that sounds about right. But what's interesting, I think, is the way I kind of termed this, and that is the evolution. And because I'm still trying to zero in on the part, cognitive by definition, okay, the smart, the thinking. But I think what I'm getting of what you're saying here is the difference is the emphasis on evolution. Now, of course, the gestation period can be really short. It could be long, but you were using an example when a turbine goes end of life and redesign a new turbine. Of course, you wouldn't have to even wait that long. Kind of the essence is kind of this reproduction or the evolution of taking the digital twin, learning from it, creating a new physical version, learning more of the digital twin, creating a new physical version. Is that the essence? Is that the essence of what you're saying?
Yes, because when we talk about cognitive, Bruce, let us talk for a minute about the artificial neural networks. The major difference between using artificial neural networks to take a decision and data analytics or big data analytics is, in data analytics, when you want to run a report, say, give me the sales of this car model from 2015 to 2017. In North American region. The data analytics system go through all the sales data and give you a report and visualize it in a nice charts.
Yeah, like a BI.
Exactly. In artificial neural networks, it does not work like that. It works like our brain. When you ask me now a question about cyber physical systems, I don't go through all the books and papers I read in my life about this to answer your question. My brain answers immediately, because my experience, all what I read in my life affected the structure of my brain. And when I have to take a question or decide to answer some question or take an action, my brain function differently. And this is where we came to the artificial neural networks in the 80s and 90s, and now it is the trend. This is the same. So the digital twin, the cognitive digital twin, the digital twin is being seen as a huge database or data lake with different data coming from every direction to simulate something, to understand the phenomena, to predict a failure of machine. This is not the cognitive digital twin. And we'll talk about the architecture I proposed last year, which is cognitive. Why cognitive? I don't want to collect the data from Facebook and Twitter and every corner and dump it in a large system. I don't. Why? I wanted to use this data to create knowledge, and all of those knowledge I am creating will affect the internal structure of the digital twin, which will make it function as a human brain, or even a mouse brain, or a dragonfly or whatever. Yeah. So this is what I mean by cognitive. Digital twin is being seen a huge data lake. It is not, and it will fail, because if you create a digital twin based on this concept for aircraft engine, and maybe you heard Jeff Emlet and others talking about how many terabytes an aircraft engine creates per trip. And if you collect the data every trip and you store it, where you will store all of this? Where or which computing power would you have to analyze all of this data? We have to embed artificial neural network, cognitive computing architecture everywhere while we are creating a digital twin. And this is what I mean by cognitive. So complex, but I wanted to say we don't store data. We use the data, the digital twin, collect from its physical twin and the other external sources to change the internal architecture, internal parameters of a digital twin system.
All right. So what I'm hearing then, the evolution maybe is part of this in the sense of augmenting the artificial neural network, but really that's the key. And the key definition, I guess the general definition now of a digital twin, and this has been changing. Everyone's been listening, change it as I've been listening or talking to more people. But I'm thinking, where my head's at right now is a little bit, they're saying, and I think that's the difference between the cognitive, is it is a pool of data associated with an entity, and then its related models. And those models, generally, they can be statistical based, they can physics based, they can be natural phenomena based. What you're saying, and then I actually separate the simulation from the digital twin, because I feel you can put the digital twin then into different environments, different simulations, so to speak, and then see how it acts. But what you're saying is, no, the digital twin is actually sure all the parameters. So the type of data, storing some data that is the control data, what it is, what it does, maybe some of the physical data as well. But more, instead of the raw data, what you're saying is you're storing this artificial intelligence, this artificial neural network that goes along with the digital twin, instead of the data that would be created with an analytics system to models to execute and then do different things. So you're kind of evolutionarily jumping one level. Yeah, am I getting?
Yes, this is right, Bruce. But cognitive is not replacing the analytics. Like us as a human, if you and me today have to take a sophisticated engineering decision, are we going to be able to land safely on Mars or not? What we do, we use our cognitive capabilities and some analytic capabilities to take this decision. It is not either or. Therefore, the cognitive digital twin, the core design, should be cognitive design, cognitive computing design. From the hardware perspective, mainly will be a combination of traditional computing engineering architecture and neuromorphic computing architecture together. But all of this will not replace the analytical part, which you and me as experienced humans still use until today. We cannot ignore it. So it is not either or, both will be together. But what I am evangelizing for is, let us start this new generation of systems and machines based on cognitive architecture, not data analytics architecture, because it will fail. Simply, it will fail. It will not add the promised business values. Therefore, business leaders will decide to shut down and stop the whole project. Yeah.
So, okay, then I think, so you're not saying replace the data or the models or the analytics and the data and the models for the analytics, because that is definitely an important component, but you're saying in the cognitive capabilities.
Yes.
So, Ahmed, can you give us a simple example of an architecture that would be based on traditional computing versus one that is using neuromorphic computing? Just a very simple one for our listeners to say, oh, what does that mean? What does it mean to then introduce this neuromorphic or cognitive type computing into our code?
Sure. Different companies today have something they call digital twin, mainly in heavy machines and critical systems simulation. What they have done so far is take, for example, cognitive twin to predict failure in a turbine, for example. Mm-hmm. And what's happening is you get some design data, some engineering data, some material data, some operational data, and say, if the temperature here is higher than 120 degrees Fahrenheit, shut down the turbine, for example. Yeah, very simple. Okay, but this is a very simple case which a human being can do very easily. So you had engineers from, take, for example, GE engineers who built the machine, operation experts on the customer side, sitting together, long time, creating knowledge models, data models, installing sensors, connecting software data defined networks, and all of this work, time and money. And at the end, to tell me that if the temperature is higher than 120, shut down the turbine, this is not added value. No business leader will sign on this. So what I mean by that, and here this brings us, Bruce, to the other part, which is the cognitive part, the cognitive architecture. What I'm proposing here, and our audience can go to my LinkedIn. I bought the contents of paper I published last year. They can read and happy to hear ideas, recommendation, critics, and all in between. So I am proposing two parts. The first part I call the core of the digital twin, which could be it will be nearly complete once you installed or commissioned a physical twin. We collect design data, say, for example, from PTC Creo, for example, or Dassault or Siemens, and those data are there already digitally created from the beginning, yeah? And also we need some material data, some components data, some manufacturing data, operational data. All of this data should be stored in a form of data as well as knowledge in the core of the digital or cognitive digital twin. But all of this data and all of those initial knowledge will not help too much. What we need is to build a body around the core of the cognitive digital twin. You need to continue collecting data, operational data from your physical twin, other related data from external sources, and update your knowledge, again, update your artificial neural networks embedded in your core to create the knowledge and the wisdom, if you will, a digital twin needs to take action and decisions. So you need to continuously collecting data. I call this is a data layer. I call it in my recommendation data anchors, but you can call it whatever you want, but it is the data collection part. But once we have this data, we use this data to create the knowledge. As I mentioned, there is another layer responsible for creating knowledge. Another layer will be responsible for the interaction between the digital twin, its own internal components, the digital twin, its physical twin, the digital twin, and humans. So the digital twin will be able to communicate with us in a human way. We call it augmented reality, virtual reality. We have, as you know, very advanced natural language generation using in artificial neural networks and deep learning. We have natural language processing. So you see now Siri, Alexa, and alike, they can listen to us. they understand us, they can generate natural language using artificial intelligence techniques. So this layer will be responsible for communication, internal and external communication. The other part, which if you are implementing system, you will understand it very well, Bruce, which is those systems, a digital twin will be a very complex system. And my colleagues on the system engineering side understand that when we started to create cyber physical systems, then it's getting complicated. And we know that we came out with the system of systems engineering. And then we have a very complex cognitive system called cognitive digital twin. Managing those systems is not easy. So think about it. We, as a business leader or IT leader, you think about how I am going later on to administrate, to manage the system, to operate the system. We managing such systems will be beyond our human capabilities. And my colleagues who are managing SAP systems, Oracle systems, Microsoft knows this very well. We have to think from the beginning in the initial design to use artificial intelligence and the other tools to automate the management of such systems. And this is what I call the self-management component of a cognitive digital twin. The last one is there is a concept in systems. If you cannot secure it, do not use it, right? Because it is a digital twin. And we know now the cyber security hacks everywhere, cyber physical risk everywhere today to our whatever smart grid or other physical infrastructure. There should be, and we know the trend in cyber security today is to use cognitive computing to secure our digital systems. A digital twin should have its own capabilities to digitally defend itself. But it is not only this. The digital twin will have the responsibility to defend its physical twin as well. Because if my brain and my eyes cannot protect my body, they are useless, right? So the physical twin, this for a digital twin, those machines use video analytics, stream or video stream analytics, use whatever cognitive capabilities to secure yourself as a cognitive digital twin as well as your physical twin. Because you as a digital twin, you are a major weak point in the security of the physical twin, right? And we know today, if you connect a physical component of our infrastructure, we say this is a risk because you connected it to the internet. And once you connected it, it can be hacked. Using cognitive capabilities to reduce the cyber hacks is mandatory component of a cognitive digital twin. At the end of the day, it should be cyber or digitally, physically secure system.
So what I'm hearing is cognitive computing. Well, I guess it should be obvious. That's the difference between that and a digital twin. A cognitive digital twin is the cognitive capabilities. But dissecting that a little bit more, yes, you've talked about using the cognitive capabilities for managing the system of systems. We all know a cyber-physical system and an IoT system of systems. You've also talked about using the cognitive computing capabilities for security, and we're doing that a lot specifically in the OT network and the operational technology network, using there's something going on here. So using instead of trying to block things, security and so forth. So I'm all there, but where I'm most interested is using the cognitive abilities in decision making. And right now the architecture is this. So we have our physical, and like you said, we sense a bunch of data. Some of that data is from the actual object itself. Some is environmental. Some are from external systems. Some are from the sensors themselves. We have raw data. From that raw data, we develop types of models for different purposes. The example you used was to look. We can also look in the present and the past, but to look in the future and say, something's going to break down. Now, the example you use, of course, is a very simple one. When you're talking about these statistical models and the amount of data that we're talking about, it's very much a multivariate equation that can be a thousand points long or variables long, as opposed to one saying, is this above or below or above us? Shut it down. Of course, we could we could have thousands of these, and then a correlation between all these thousands. That's what's really good. That's what analytics is really good. But now what you're saying is we're adding a different type of model. So we have the models that we compute with analytics, and then we execute the models, and then we execute the models or interrogate the models for different purposes. I think what I'm understanding you to say is now we also have the cognitive models, and we're using cognitive computing or these artificial neural networks to develop a knowledge in addition. So it's a type of model that's based on data as well, but it's just a different type of model, use this different computing, construct to come up with a neural network. And then using that, the one that's been developed with the neural network, and maybe using it means using the neural network on it. I'm a little bit ignorant there. But in this more sophisticated artificial intelligence network or cognitive computing model, I should say, for making these decisions or gaining these insights. Am I getting close?
Yes, no, you are correct. You are correct. And there is a principle in system engineering, Bruce, is a system which should take decisions in real time cannot be only based on data, because as I mentioned, like you and me, I didn't come today to you with all the books and white papers I read in my life to answer your questions, right? We are real-time system. We take decisions, we take actions mostly in real time and instantly. So a digital twin will be exactly the same. And if you want a digital twin for a turbine, for aircraft, because if you have a digital twin for aircraft, this system will have, to add the expected values, will have to have or take decisions in real time or near real time. Therefore, those systems can be only cognitive systems, in my opinion. Otherwise, you are talking about simulation systems, and we have a lot of them across the globe. Specialized, generalized simulation systems, and all in between. So you are correct, and this is why I'm saying those are real-time systems. Yes. Okay, we have to design them from the beginning cognitive.
Okay, so this is now we're putting a finer point on it. So it's not all type of analytics, but what you're saying is, and I'm going to get to cyber-physical systems in a moment, but what you're saying is specifically for present, when you're doing analytics and putting analytics in real time, this is where the cognitive, you can do it statistically, but there can be people, like what you're saying, is it above 120? Of course, it can be more complicated than that, but there is limits. We can all understand that. Yes. Even with the in-memory computation and so forth. But what you're saying specifically is instead of a simulation in real time, use the cognitive computing. And this is interesting because I'm by no means an expert in cyber-physical systems, but what I do know is the biggest problem, the scientists, the people like you, with these that are trying to figure out relating the dimension of time, right?
Yes.
And that is the time dimension, the physical world with the cyber world and together. And this, I think, is kind of looking at it from a different, but is what you're saying, getting down to the root of this is using a cognitive system to be able to make real-time, sophisticated real-time decisions.
That is correct, and this is lesson learned from designing cyber-physical systems. Right. The time parameter, the space and time and other parameters, as you mentioned, could be thousands parameters you have to consider in your decision as a CPS or as a cognitive digital twin. And for us, I will go back to us as humans. The time for us means experience, and the experience from the neuroscience perspective is not just we store the data or information in our brain, but also it affected our brain internal architecture and internal parameters that we call it wisdom, experience, you name it. So time for us is maybe scarce, but wisdom and experience. And this is not data. It is experience. This is our architecture. This is exactly what I'm trying to highlight as a concept, as a design concept for the cognitive digital twin. Yeah, and it's simple too. I make it very simple for everyone listening to us now, Bruce, is are you going, if you are creating a digital twin for aircraft, are you going to store all the operational data for thousands of aircraft to be able to use the concept of digital twin? You cannot. And if you stored them, you cannot process them in near real time to take a decision for your aircraft. You cannot. Engineering-wise, it is impossible. Sometimes I say, it is a stupid engineering concept or approach to go this way.
But to be clear, you are correct for real-time decisions. However, I think you can make the argument that you should indeed store, if you have a good data strategy, you should indeed store this data, because there's certain types of operations, like you said, that analytics, maybe going back and taking a look at what happened there, or going in future and maybe having a different way of saying, maybe in a long time, there are these analytics computations that would indeed benefit from the data. In real time, getting back to real time, all that data is of no use because there's no way we can possibly process it. But you agree, if you do think that there is value in analytical processing, then keeping that data isn't a waste, right?
Exactly. It is, but it is not a waste. But I do believe personally, Bruce, that we are moving from, so the last 2 decades, we're talking how much the volume of data we are gathering or creating and collecting as humans is doubling every, 8 months or 10 months. This marathon will end, in my opinion, soon, because we are in a race which we lost already. Why we have to collect all of this data from different sources? Why? And where are we going to, and when are we going to use all of this data we are generating and collecting? Again, go back to the humans. If I say I met Bruce 10 years ago in San Francisco, my impression about this person, he's a kind person, he's a good person. Impression here, this is a human evolution here. I don't remember exactly what did you say at the time 10 years ago. What food do we have together? But I have the impression still today that you are a good guy. So I reduced this is what we call data compression in the human brain or animal's brain. They do the same. They compress the data and they move on. Compress the data, get rid of part of it, and move on. So this is going to start soon, but the race of collecting data will end soon as well.
Well, I mean, this is interesting because it does bring up other thoughts that I have, and the first one is I'm becoming increasingly in the belief that your digital twin, designing your digital twin, and like you say, if it's possible to do it from the beginning, that's even better. We've got legacy systems, but in designing the digital twin, you are in fact designing your data science structure, because of how your relationships between the different data. Now, what's interesting in what you said, and you've brought this up in a whole different ways, is this compression that goes from data to information to knowledge to wisdom.
Exactly.
And the argument that you're making is all this data, it's too much. We're seeing now, and I'm actually working with one of my clients right now on our data science strategy, is actually getting rid of the data but keeping the information. Right? And so that is one level of decompression. And I think when you get into the cognitive computing, something I'm still pretty ignorant about. However, when you get into the cognitive computing, you can actually maybe move beyond information into knowledge. And then I don't know about wisdom. Maybe right? But in effect, it is on this continuum that we're talking about, and you're making the argument that there's so much data, we need to have a higher level representation of it, or we need to compress it, depends on how you look at it. And this is something that a cognitive system is really good at. There may be other ways, but this is something a cognitive system is really good at, a la your example of us meeting 10 years ago. Yeah, you don't remember the data, all the data, but you do remember, I remember the information, or I know, or I have knowledge, you have that. And so this is interesting because it makes a lot of sense, and again, you're following the evolutionary kind of cycle as well. But, anything to add to that? I mean, this is starting to resonate with me now.
Yeah, I think Bruce here to add is this is complex stuff, right? It is not easy to implement. Especially there is a lot of work to do. Actually, the major problem I see is the human skills. You don't have enough skilled people to get all of this done, and it will be step by step. And therefore, I said, okay, if we want to do that, we have to split it into different categories of cognitive digital twin. Okay, and I split it into 4 major categories. The first one, what I call machines, cognitive digital twin, large machines, turbine, which we call it today in system engineering, system of systems. A turbine is a system of systems, is a system of physical systems connected together in one body called turbine. And now I call it machines cognitive digital twin. The second category, I will not go maybe deeper in all the details, but the second category is the sensors, or what I call objects, digital twin. Because sometimes we'll have in the physical world a sensor, a camera. Take the traffic lights we have today. They are going to be replaced by just maybe cameras streaming videos about the traffic patterns to smart connected cars or driverless cars. And all of this information will be used to manage the traffic of driverless cars. So for this camera, I will need, call it mini digital twin, not sophisticated, not complex digital twin, but a digital twin for this camera will be able to connect with all the digital twins of the cars geographically or spatially exist in the perimeter of this traffic light or intersection, and smoothly control the traffic without all the traffic lights infrastructure we have today. So you need a mini digital twin for objects, physical objects. The third one is what I call human cognitive digital twin. And we know there are a lot of research here to dump it, to digitize the human brain and all of those. But I make it simple. If there is a digital twin for me today, which has my experience, my education, my health information, maybe other information, and can my physician serve me better? Yes. But also I go to another application. When I am operator or operating a machine with a digital twin, my digital twin will work with the cognitive digital twin of this specific machine that we, the machine, its cognitive digital twin, me and my digital twin will work together to imagine the performance we all together can do. Simple version, it is Alexa. Exactly. So we as human will be served better if we start to create a cognitive digital twin for us, even if it is a simple version. Some people say it is a medical record, it is an education record, experience record. Bring everything together in one human digital twin. Call it avatar. I call it avatar. Yeah. Avatar, exactly. Yeah. The last one, what I call enterprise cognitive digital twin. Take, for example, many companies today have SAP as enterprise back-end system, managing different functional areas using SAP systems. Yeah, and imagine, and today ask any SAP customer or Oracle customer, big mess. Why? You have data stored everywhere, every functional area, every geography, every division has maybe its own view or version of the truth. Imagine we redesigned SAP systems or Oracle systems to be based on this concept, the concept of cognitive digital twin, where all the enterprise data in one, and as we discussed earlier, not just data converted to information and knowledge, which will enable a real-time decision by everyone in this organization. And I see some signs for that, even inside SAP and the new SAP system like S4HANA and SAP HANA, they are moving maybe unintentionally to this direction to have everything in one large in-memory cloud-based database. You have machine learning algorithms next to the data, trying to analyze the data and convert it continuously to knowledge and information to enable real-time business decisions. So we have the machine, cognitive digital twins, human, objects, and enterprise. This will help us to jumpstart efforts in creating cognitive digital twins, which will deliver the promise we promised ourselves and our clients.
No, I like the taxonomy here. And I guess I think about it in the same way, but slightly different. And I like that you brought in. I think of the digital twins, they can be leveled. So it could be at the part level, product level, the system level, and the environment level. And that sort of maps into a little bit more or less your machine and enterprise. But what's interesting that I like is then extending it a little further to the user. Now, this might be a machine worker, it might be someone an oil rig worker, but actually having that digital twin to, and you brought this up earlier, to augment the capability of the user interface, of the user experience. And that's concept. I like that. I like that because
that's good. That's a
No, I think that I like that because why? Because it is an extension of the digital twin into the operators, wherever those operators may be, and it just makes the whole system more efficient because, as you said, really what we're talking about here is an interface, and we're talking about a human-machine human whatever interface, computer interface, but by having this additional twin, just like the machine has a physical body has the human body, but have this digital representation that can help with that interface. Yeah, that's pretty cool.
Yep, that's correct. And I actually had a couple of days ago a discussion with my friends here at the MIT Media Lab. And one of the research they are doing, and it is actually a product right now, is to use, they created a mini digital twin which can even recognize its physical twin. And say, for example, you can have the digital twin using augmented reality or even just on iPad screen and touch, and you can just maybe, for example, I am a digital twin for the light bulbs in this room, but I can be also the digital twin for lights in the whole building, for example. So it recognizes its digital twin and you can control it. It is a completely different concept driven by the concept of cognitive digital twin. There are a lot of opportunities, Bruce, but back to your note here is, if you have the human operator, take, for example, an oil rig, for example, you have a digital twin for different equipment and in one digital twin or cognitive digital twin for this specific rig, you have 100 workers and engineers on this rig, and you have kind of cognitive digital twin for the workers on the rig. Imagine this will create kind of a digital swarm, what I call it a cognitive digital swarm. They come together based on the task now, and we come together, the digital twins come together to serve the physical twins. The physical twins could be machines, could be human, and make it kind of an efficient, effective team in ad hoc way. And this is technologically is possible. It is to change the way we architect systems, but the technology we need to start at least creating the first generation, all the technologies are there. We don't need new technologies to make this happen. It is a mindset change here, which we have to do.
No, absolutely. And we're describing the same things with a different vocabulary, but the swarm, it's central. I mean, and it's central to being able to deliver outcomes. And there's not a physical product that's going to be able to do it alone, generally speaking. It's going to require multiple objects, right?
Exactly. And this is a basic definition of swarm intelligence, that you don't need very smart machines coming together to do complex tasks. But if you have, say, average machines with average intelligence coming together like an efficient team, they will do miracle. And this is the basic definition of swarm intelligence. Use not intelligent machines to achieve higher level of intelligence. And this is exactly what we need today.
Yeah, no, fascinating stuff. Ahmed, I feel like we can continue this conversation for a long time, and we may, and when we hang up on everyone listening, sorry. But before we finish, because we are out of time, where can people find out more, about you and the work you're doing and what Accenture is doing in this space?
Yes, about myself and what I am doing, I think my LinkedIn should be the right place to go. Okay. But what we are doing at Accenture, just go to accenture.com and you will see all of those technologies needed, whether the artificial intelligence technologies we have, the cloud, the in-memory computing, big data analytics, all those what we call liquid architecture, liquid interfaces needed to interface with such systems. All of this information is there already. However, I am personally available to answer any question from your audience.
Excellent. Well, we appreciate that. And with that, I'm going to thank you. Very interesting. I think you added an extra layer for everyone to consider, specifically the computing layer and how it can help really IoT at certain levels. So with that, thanks, Ahmed, and we'll be talking soon.
Thank you, Bruce, for having me. It was a pleasure talking with you.
Okay. That was a very good talk with Ahmed El Adl of Accenture. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support the show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is the profound impact of IoT digital twins in supply networks with Lane Warshaw and Aaron Perrott of Deloitte. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Till next week, may your path to IoT business be a smart one.
You have been listening to the IoT Inc. Business Show.